one. So this is the stochastic. Whereas batch gradient descent means I'll present all the four data samples at a stretch. I will take the error, and based on the average value, my weight of decision will be takes place. So this is the difference between stochastic gradient and the batch gradient descent algorithm. Next comes to the linear classification model. I already said the classification model is difference between linear regression model and the classification model means my classification model, the output will be a categorical value. So if it is a categorical value means I can say it is a classification model. That means it should be a, if it is a linear classification model means the here this red color belongs to class 0 and this green color belongs to class 1. So these two I have to separate it. So here some data may be present in it, but some may be present in the alternate. But our target should be as minimum as possible. Okay, the number of wrongly classified samples should be as minimum as possible. So here class 0 and class 0 we have separated with this two line. If you want to accurately define these two means, so it is an overfitting. It can't able to get a proper accurate answer for the future. Next comes to the difference between linear regression and the logistic regression. So if you take this two simple, I already said linear regression means my red color will be a straight line. Here my red color line will be your S curve. So if it is S curve means it is a logistic regression. So here this straight line will be used for the linear regression problem. If it is S curve means it will be used for the classification problem. Next comes to the support vector machines. So what does mean by support vector machine? If you take this diagram, so here what is a support vector means? So here this is the samples which belongs to the one class, and this is the subclasses. So I already said our target we have to make as close as this one. So you have to define the line which should common for this. So how we will be defining it means we have to define the margin. If it is an positive hyperplane, this is your negative hyperplane. Other sample. Okay, so this is my hyper boundary factor, and this is my negative hyperplane, and this is my positive hyperplane. So the margin between the positive hyperplane and negative hyperplane should be gap between higher. So that is here. Moving as support boundaries. Okay, the support vectors are the data that lies closest to the decision box. Okay, so that is my support vector machine. So here classifiable distance d minus d plus. So here this samples which is very close to the one they are taken as the support vectors. So our objective is used to minimize the weight value. So next comes to the decision tree. We already said the decision tree is nothing but it is used for classification, binary classification model. Binary classification is nothing but the classification which contains two classes. That means the target value contains two classes. So here, this is the decision tree. We will be taking, we will be deriving the rules from the data features. Based on the rules, we will be classifying it. For example, here, age is one of the features, weight and smoker. These three are the data features of the data set. So how we will decide weight, age and smoker is a root class. First, we have to calculate the information gain for each and every features, and based on the information gain, we will decide which one is better, and we will be decide the root place. And based on that root node, again we will be calculating the information gain for the remaining data sets. So based on this, we will decide weight and the smokers and left child and the right child. So this will be repeated for each and every node in the decision tree. Once the decision tree is constructed, we'll start from the root node. If the weight is less than or less between 18 to 30. So if it is greater than 30, again I'll go for the smoker attribute. If I'm a smoker, I can say it's a high risk. If I'm not a smoker, it is a low risk. If my age is less than 80 means I'll go for weight. If it is less than 60 means low risk. If it is greater than 60 means high risk. So accordingly, my target is either low risk or the high risk is my target. So I can say it is a decision tree, binary classification problem. Next comes to the random forest. Random forest is class, and this is for I'll be constructing the multiple decision tree. Okay, so then how will it reaches a single result means, so based on the majority of the output, this is derived from the multiple decision tree. We will take it majority of here. If we take it, this is the collection of the instance. We will be constructing the different decision tree. So here the output from the first decision tree is class A, and second class tree is D, and the nth tree is class B. So as per the majority, in the class, that means class A has been categorized more. So majority voting, I have decided that this will belongs to this final class. The random function is works on the baking principle. Baking principle means parallel principle. So here my data set, I will be creating the multiple baking principles. Next comes to the confusion matrix for the binary classification problem. So this is my binary classification problem. I'll just stress through it because so binary classification problem. How my binary confusion matrix is nothing but evaluating the performance of the classification model. So based on the testing, first I will be dividing my data set into training and testing data set. Using training data set, I will be training the model. Once the system has been trained, I have to evaluate the model using testing data sets. So using the testing data set, I will be creating the confusion matrix for evaluating the performance of the performance. This is actual value means the value which is Excel sheet. Predicted value means the value produced by the system. So here, if it is binary class means one is positive class and negative class, and then actual is positive. If positive value is predicted as positive means it is true. The negative class is actually is correctly classified as negative means it is true. This true positive and true negative is the classification. Whereas the remaining class being detected as negative means it is falsely detected as negative. Actually, it is negative class, but it is categorized as positive means it is falsely classified as positive. So based on the binary classification, I am able to classify two class substance data set as belongs to so total number of instance is 699. Number of classes 2. One is malignant. Class is 458. Malignant class is 241. So I have divided my 699 input sample into 20%, that's 489, 30%, 210. So here testing it means training percent 3. So training 70, this 30%. Among this, Benning class training contains 321. The management class contains 168. Totally 489 samples are there in training. And then in testing 210, out of 210, 139 samples belongs to Benin and 73 belongs to malignant class. So totally 458 malignant class and malignant is 241. So keeping this mind, I'm going to fill the class this one confusion matrix. So as for this version, I have filled it. So here, out of this, 321 has been classified as this one. This is the total representation of my one. So everything I explained. So here, Benin class. Benin class is classified as 120, and the management class it is classified as 13. That means it is false positive. This is false positive, and negative. So this is 130, and this is 7. Okay. So here 137 and 73. totally 210. So how will you calculate the classifier's performance means here error rate. So whenever the incorrectly classified samples divided by total number of samples in the testing data set. Best value is 0 and worst value is 1. That means if this error rate means you should move towards the value 0. If it is accuracy means you should move towards the value 1. If it is in the form of ones and zeros. If it is percentage means it should be as close as towards 0. If it is accuracy means it should move close towards the 100%. So this is the error rate. That means diagonal false positive and false negative divided by total number of samples. That means malignant wrongly classified as 13 and this is 17. So 13 plus 17 it is 30. 30 divided by 210 it is 0.4. That means 14 percentage. 14 percentage of accuracy is 14 percentage of this one is here 13 percentage and here it is 17. Totally 30 percentage are there. 30 percentage divided by 210. So 0.14. So 14 means 14 percentage has been wrongly classified. That means error rated. It should be as minimum as 0. So what next comes to the accuracy? It is correctly classified sample. The formula is true positive plus true negative divided by total number of samples. Here true means 120 plus 60 it is 180. 180 divided by 210 that is 0.86. That means you can find it another way also. 1 minus error rate is 0.14. So I can get 0.86. So 86% accuracy is there. 86% accuracy is there. That means error rate can be derived from accuracy. 1 minus accuracy is error rate or accuracy is 1 minus error rate is here. This one. So 1 minus 0.14 is 0.86 or 1 minus 0.86 equal to 0.14. So this is the accuracy percentage that we will be calculating. So similarly, precision value. So if we know with the strong with the parameters, what are the true positive, true negative, true false positive, false negative means I can able to calculate the remaining thing, precision, recall, specificity, F, there is F score is there, AUR, everything can be calculated in very proper manner. Just I'll look into the confusion matrix for multi-class. Since many of you are will get confused with the confusion matrix, just I like to give a brief knowledge what I have strongly understood. So again, this matrix. Here, which one is will be taking as one class and the another class is it? Except that one entry it is a negative and the other is a true negative. That means the row on the same row will be a false positive and the same column will be a false negative. The remaining thing is your true negative. You have to consider this. Except that cell, the corresponding row, all the entries is a false positive. The corresponding column is a false negative. Remaining string is your true negative. So here, if you take it, so if you consider this class set, three data sets are there, three classes. So 150 instant, 4 attribute, 3 classes, 50 per. So we have divided into training and testing, 60, 40. So 90, 60 have taken it. So this is the difference we have taken it. 90 for training and 60 for testing. Now we will be looking into this. So here when you take this, we have to go for three classes. For iris itaso, if the cancers, I will take this entry as that means iris itaso is correctly classified as iris itaso. It is a true positive, and this is false positive. This is false negative. Remaining thing is a true negative. If you take for iris versicolor, this is true positive, and this is false positive, false negative. Remaining thing is a total negative. If you take iris vertica, so here this is true positive, and these two entire false negative, and false positive, and this is a true negative. So this is the way you have to calculate it. If it is for depends upon the number of classes, this class confusion matrix will vary. Okay. So this is from the value you will be taking everything. Here iris predicted value we have taken it. Matrix incorrectly password. If it is for correctly accuracy means here this is the correctly classified value. 15 plus 14 plus 15 is accuracy. The remaining is here. This is for accuracy value for iris citaso. It is 28%. Accuracy means 15 plus 14 plus 14. Okay, so this is the way that you have to calculate it. This is for only one class. So remaining class you have to go through. So this is any doubt with respect to this confusion matrix. Similarly, once you're familiar with the terms false positive, false negative, true positive, true negative means it is very easy to compute the matrix classification matrix here. Any doubt with your confusion matrix? Any doubt you can clarify it here. Any queries regarding the regression and the classification basics? Or do you need any clarification or anything? Please let me know so that I can able to share it. If you're not having any doubt, shall we wind up, ma'am? Okay, ma'am. Thank you so much. Yes, I have given the contact detail. If you have any doubt or any guidance you needed with respect to the implementation of part, you can just ping me to this number or to my mail ID. So this is my mail ID and the mailing number. You can contact me for any help. Thank you. Thank you. Thank you, sir. Thank you. Thank you all.